Our next speaker, which is Reinhard Ringdorfer from Unitherm Cemcon, also based in Austria. He's going to talk to us more about satellite burners, secondary fuel firing through the MAS kiln and the Unisat satellite burner. Reinhard has a master's degree in chemical engineering from the Technical University Graz in 2000. He spent the early years of his career with PMT Zyklon Technic, both in Krems, Austria, and Kuala Lumpur in Malaysia, where he was responsible for sales across the Southeast Asia region. He then moved on to Unitherm Cemcon in Vienna, where he's now sales and project manager for Western Europe, the Americas, and Asia. Unitherm specializes in the supply of highly advanced tailor-made firing systems for the cement, lime, and mineral industries. And as I said, he's going to talk to us about the satellite burner. So Reinhard, please share your slides and welcome to the webinar.
So thank you very much. I hope you can see the presentation.
Yeah.
So good afternoon, everybody. First of all, thanks a lot, Thomas, for giving us the opportunity to present our findings here, our, let's say, research that we have done in the last many years, to be honest. And I will mainly talk about, let's say, the execution. Fortunately, Joel, he already explained a lot of the theory of the combustion of secondary fuels. So I can skip this. So we'll go to the burner and to the satellite burner, how we can help the client to burn more secondary fuel. And at the end, also, we will have some case studies. So, okay. First, I want to discuss a little bit, or just show a little bit, what types of secondary fuels can be fired, where they can be fired, what has to be considered when you fire secondary fuels. Then we will go briefly to the firing through the main burner, and then coming to our, let's say, main topic, the satellite burner, which is getting more and more interesting in the last few years. And I will close the presentation with some case studies for both cases, through the burner and the satellite burner. Okay, first, just briefly to introduce everybody who doesn't know Unitherm yet, a little bit of our company history. The company was founded in 1945 here in Vienna, building mainly oil burners for household, for heating. Quickly developing into other industries until 1953, the first kiln burner was installed. And we were using 3-channel burners, 2-channel burners, until the invention of the MAS technology, the patent and invention of MAS technology in 92. In 97, there was a change of ownership, which means our owner from then to now was, or is still, Mr. Lederer. He bought part of the company, and the strategy was changed, that we more or less take care only of mainly of the cement market, mineral market, any let's say application with rotary kilns. Yeah, and since then we moved to a new office building, and to complete the story, since then, 1997, since we focus only on this industry, we have installed more than 600 firing systems in 92 countries up to now. I think most of you know our, let's say, scope of supply. We can supply all the firing system necessary for the cement industry, all the burners, all fuel handling systems, except for solid handling systems, with our main product, the MAS kiln burner, which is available in numerous executions for multi-fuel. There is one special execution for natural gas. We are doing also tests with hydrogen, traditional fuels, alternative fuels. Everything is available. So if you need any more information, you just go to our homepage or contact me, and we'll give you some more information. Okay, now starting with the secondary fuel. We heard a little bit about the theory here. You can see some pictures. There are numerous secondary fuels available in the market. Some are well prepared, some are not so well prepared, and we have to differentiate about for fuels which can be used in the kiln, which can be used in the calciner, because even the best burner cannot use fuel with too high moisture, with too much 3D particles, with too big particles. There is some limits from the physical side that we cannot change. We have made this small diagram where you can see the ratio of the 3D to 2D particles, the moisture content, and the particle size. And you can see there is basically a very small section which can be used in a normal kiln burner through the main burner itself. We have made, let's say, several inventions or devices for the secondary fuel channel in the burner since more than 20 years now, to influence the behavior of the particle coming out of the burner. The last invention is the pneumoreflector, which is also in use for more than 10 years now. I will go to that a little bit later. So here you can cover a little bit bigger area. The next step would be the satellite burner, where we still have a little bit more freedom in regards of size or humidity or moisture of the particles. And the rest, which was also explained earlier, is combustion in the pre-calciner, because you don't need a really defined flame in the pre-calciner. You just need to release the heat, not at a specific point. And of course, also you have a higher retention time in the calciner. So for most cement plants here in Europe, it's very common to know what to do when you fire secondary fuels, because they're doing it for 2 or 3 decades. But there are some things which need to be, let's say, taken care of when you want to start firing secondary fuels in the rotary kiln. So first of all, compared to primary fuels, you need more oxygen content in the kiln inlet, usually around, or we recommend 3 to 5% in the kiln inlet to ensure a complete combustion, to ensure that you have no CO present at the kiln inlet. Also, we heard before that depending on the secondary fuel you're using, you have to adjust your raw mix to get the desired results of your clinker quality, of course. Most of the time, if you're using RDF, some kind of plastics, anything else, you're introducing additional sulfur and especially chlorine into the system, which we all know tend to form cycles in the kiln preheater and can lead to blockages in the preheater itself. So this has to be considered. We have a possible increase in the kiln inlet temperature, of course, because even the fuel is very well prepared. It's not as well prepared as coal, for example, or petcoke. It takes a little bit more time to combust in the kiln, and therefore you will have a delay in the combustion. You will have a delay in the heat transfer to the clinker, and therefore a higher inlet temperature. Of course, you have to have a main burner which gives you all the freedom you need to adjust in any direction. And you also have to consider that you're introducing additional, first of all, moisture into the kiln, which needs to be evaporated. You're introducing additional cold air because of the pneumatic transport, which can or will increase the specific heat consumption of your process. Okay, as I said before, shortly after our focus on let's say the rotary kiln process, the cement industry, we delivered the first burners with secondary fuel firing capabilities, so with a simple pipe through the main burner. And since then, we were looking for solutions to increase the the amount that can be fired through the main burner by somehow influencing the particle when it leaves the burner. So in the latest, let's say, device invention we are using is the pneumodeflector, which is around for the last 10 years. And the goal is basically to deflect the particles above the kiln burner axis to alter the flight path and to actually and to extend the residence time, the flying time, and therefore the combustion time. Here in the picture, you can see a burner with two of these secondary fuel pipes, and you can see the openings here with different angles. Usually this is supplied by the primary air fan, can be also supplied with a separate blower, and can be adjusted from the cold side of the kiln. Yeah. Here you can see the theory behind this. We have tried different approaches, increasing the injection speed, using swirl and so on, but ultimately only the deflection of the particle above the kiln axis will give you an increase in a residence time and therefore more time for combustion of the particles. And that's why in this regard, at least what we have seen by using the pneumodeflector, we can increase the secondary fuel amount through the kiln burner, let's say same quality with same clinker quality by 5 to 10%, depending on the fuel, of course. Also, over the years, we have developed two different possibilities to introduce the material into the kiln through the burner. First, obviously, we have the circular channel, which is let's say, the standard execution. But of course, with this pneumodeflector, which is let's say, independent air supply to the nozzle at the bottom of the secondary fuel channel, needs a certain space. And of course, if you have to build a bigger central channel, the rest of the burner will be bigger, will be heavier, will be more expensive. The advantages are very clear here. Due to this pipe-in-pipe system, we are able to take out the secondary fuel channel during operation if there should be any kind of damage to the channel. The deflector air can be adjusted independent of the central air, but as I said before, it requires more space in the center. The other solution is the semicircular channel, which is a half-round channel, more or less. Of course, on the back side, you will have a normal flange connection. This is installed inside the burner as a complete insert, so there is no way to take it out separately. So if there is damage, you have to take out the complete internal of the burner. The deflector air is used from the central air, so you can adjust only central air and deflector air together, not separately. But on the plus side, you have less space requirement. It's much smaller than the other execution, and therefore you will get a smaller kiln burner. So depending on, let's say, what is the target, how much you want to fire, what are the limitations of the kiln, we can choose both of these options. All right, then now let's come to the satellite burner. Some basics, more or less. We heard before, so, I mean, the satellite burner is around for, I don't know, 30, 40 years already. I know from cases where middle of the 80s or end of the 80s, some plants in Germany start injecting just through a fixed pipe, injecting beside the burner, above the burner. But first of all, let's say a naked pipe tends to burn down in this atmosphere, and then the results were not really satisfying. So by, I think I would say end of the 90s, beginning of 2000, when the secondary fuel firing started, Unitherm and also I think all the other suppliers decided it will be much better to fire the secondary fuel through the burner. A few years back, actually in 2014, we started to get back to the satellite burner, let's say, design. And we started to do our first tests. And there are some obvious advantages compared to the firing through the kiln burner, which is first of all the location of the satellite burner, which means you have a high amount of oxygen available, and you have a very high temperature coming from the secondary air. So when injecting the material, you start the process that we heard before. So you start the drying, you start the devolatilization, everything still before the particles reach the main flame. So this is a definite advantage, because if you do this when it leaves the burner tip, you have the first distance, I don't know how much, depending on the moisture, where you have to evaporate the water, where you have to devolatilize the particles, and then you can ignite the particles. Which means by doing so, you have a higher residence time. And this, of course, is optimum for your combustion. The thing is that beside a main burner that is capable of adjustment in any direction, high burner momentum for good mixing, you also need a satellite burner, which also needs to be adjusted. So it's not a fixed pipe anymore. The satellite burner is designed for axial adjustment, horizontal and vertical adjustment, to find the optimum position, to mix the particles you're injecting with the main flame, that the primary air jets can mix the secondary fuel with the primary fuel, and you have a combustion of both fuels together. So as I mentioned before, here, usually the satellite burner is located a certain distance behind the burner tip. Here you can see the execution for where the satellite burner is directly on top of the main burner. It's actually located on a small burner trolley, which gives you the possibility of adjustment plus minus 500 millimeters in axial direction. And if it's located on the burner itself, you also have the possibility of a vertical adjustment of the tip of the satellite burner. Horizontal adjustment will be also included if the satellite burner will be located beside above the main burner, so not if it's not sitting directly at the main burner. This always depends. If the satellite burner is delivered with a new main burner, then it's easy because you put it on top. But if you install it at the existing location with existing burner trolley, then you have to find the spot where you can put the satellite burner. With our satellite burner, it's possible to have both executions. So you have the suspended design burner trolley, where we can use either the frame, the support beam as burner trolley for the satellite burner, or it's a possibility to have supports depending on the space availability below the main burner, that we can have the satellite burner on top. Floor-mounted design is much easier because there's nothing on top. So as you've seen before, it would be just put the rails on top of the main burner and then the small burner trolley with the satellite burner. Okay, so much for the theory. And now I have 3 case studies, starting with the first study, which is a small cement plant in Austria. The target there was, the plant was using an older kiln burner. I think it was 2017. And even though they were using high-grade material, they were limited to 50% secondary fuel replacement in the rotary kiln. And we're talking about only solid secondary fuel. So we were assessing the situation. We offered the burner. Due to the size of the kiln and also the satellite technology was not very common at that time, the client and ourselves decided, okay, we have a 1-channel inside the main burner. And the guarantee figure was that we need to reach 70% of secondary fuel substitution. So here you can see the installation and the burner. It's, as I said, a small burner, 35 megawatts, using mainly, or the primary fuel is coal and petcoke. Natural gas is used for heating of the burner, and we have one channel with a solid secondary fuel, which you can see here, with the pneumodeflector nozzle. And as I said before, material was very well prepared. And if I say very well prepared, we're talking about at the moment less than 5% moisture and a very fine material. So we had the commissioning of the burner was done, so the 70% were immediately reached. And after optimization, the substitution rate at the moment is somewhere between 85 and 100%. For your information, the 100% is because the plant is now running on lower than design capacity. So they are allowed to fire 100% because they have a certain limit. And if they're running on full capacity, they go over this limit, what they have now, what they can fire at the moment. But at lower capacity, they can go up to 100% secondary fuel firing. So they are using only fluff at the main burner. Okay, the second case study is cement plant increase. It was a very similar scenario. They had an existing burner. They had quite good material, but they were limited to 5 tons per hour of secondary fuel firing. So they decided to install a new MS burner with a satellite burner. This is the picture you saw before, also with the suspended burner trolley. A thermal capacity of 100 megawatts. Again, coal and petcoke as primary fuel, fuel oil for startup, and of course, alternative fuel. In this case, the alternative fuel is only supplied through the main burner, through the satellite burner. Some other clients want to have let's say maybe a safety pipe through the main burner also, but in this case it was only the satellite burner. And the result were also, with the old burner, 5 tons after the commissioning, the guaranteed 7 tons per hour were reached. And after optimization, of course, depending on the material, they can go up to 9 tons per hour. Well, and for the third case, again, a plant in Austria, very close to Vienna. They have the Unitherm burner since 2003, so almost 20 years now. Again, here they were already running on a very high secondary fuel rate. In this case, the increase of the secondary fuel firing was not the first target, but to stabilize the process, to make the process easier. So also here, a satellite burner was installed. I mean, also they needed to increase the material. Anyway, the capacity was 49 megawatts, or is 49 megawatts. Again, coal and petcoke, liquid fuel with alternative fuel. And we installed the satellite burner on top. And again, start was at 2.5 tons per hour. Commissioning 3.5 tons, this was reached very quickly. And again, after optimization, we were able to reach 4.5 tons of substitution rate at the main burner. So this is just, let's say, an outlook how we see the firing of secondary fuel in the last years and also in the future. We started, as I said before, in 2015, and we have increasing numbers of satellite burners. Up to now, we have more than 50 satellite burners installed. Some are in project phase, in manufacturing. And we see, with the exception of 2 or 3 clients, that the tendency is clearly going to the satellite burner technology because of obvious reasons. First of all, it's sometimes easy and sometimes not so easy, but you can retrofit the existing system with a satellite burner, or if you buy a new burner and have the choice between burner with a secondary fuel channel inside or satellite burner, the costs are on a, let's say, very similar level, and you have more freedom, more adjustment possibility with the satellite burner solution. Well, that's all. Thanks a lot for your time, for listening, and if there are any questions, please let me know.
Thank you very much, Reinhard. A really interesting presentation and some nice case studies towards the end. Unitherm is a plant that we've had in our magazine many times. It's good to see some of the staff on this webinar today. But it's a plant that's was quite early to adopt and advance alternative fuels to very high levels. In that case, they didn't choose the satellite burner, but they've had a lot of success with burning well-prepared fuels in their main burner. Do they also use the calciner?
Yes, they also use in the calciner.
Yeah. A few questions are here. You answered the question that I was going to ask, which was really about retrofitting. Is that normally quite straightforward, or does it require any specific features in the kiln to allow a retrofit of a satellite burner?
Well, of course, first of all, the kiln has to be big enough. As I said, like in Wittersdorf, if you have a kiln which is 3 meters in diameter or 3.5 meters, it's most of the time a little bit complicated to put something above the main burner and to get the desired results. Also, especially with a suspended burner trolleys, you know, let's say maybe several decades ago, there was the burner and there was a hole for poking and for looking, but now you have cameras, you have sensors, you have everything. So for existing kiln, you have to see if you find the space where you can put the satellite burner. As I said, I've shown you now the solutions where we are above the main burner. There are some, because of space, not available when you put it on, let's say, the 2 o'clock position, even beside the main burner. This is also possible. So the first thing we have to see if there is a possibility to install the satellite burner. If you find your opening, your window, then it's almost always possible to either integrate it in the existing burner trolley, to modify the burner trolley, to put it on a separate burner trolley. So there are a lot of possibilities for installing the satellite burner.
There's a question here about minimum calorific value required to maintain good flame stability in operation. How will the high adoption of alternative fuels affect this?
Yeah, well, I mean, for us as burner suppliers, and I think it's most common that you say, okay, you need at least a calorific value of 4.5 to 5,000, let's say 4,500 minimum to get the flame temperature you need for your process. But of course, once you want to go higher, I mean, if you're talking about 20-30% substitution rate, then you can also use low-grade fuel. But if you want to go to substitution rates 70, 80, 90%, then you need, first of all, a very well-prepared material, and you need a high calorific value material also. There's no way around this. It's still not working with low-grade material.
Yeah. Okay. In terms of monitoring the flame, are you using online video thermography? What are your recommendations in this area?
I think nowadays most of the plants are using some kind of thermography or cameras or whatever. We can only, let's say, advise the client what they need. But as I said, most of the plants who want to go in this direction, they are already equipped, as most of the plants are going into, you know, the direction of Industry 4.0 and so on. So most of the plants if you're using already a secondary fuel, then you have certain measures in place to see that the material is burning.
Yes. In terms of the use of hydrogen as an enhancer, can you speak a bit about that? Is that something that you've looked into, or do you find other strategies are better?
Well, we are doing a few tests with hydrogen with a low percentage. Let's put it like this. It's the, let's say the project hydrogen it's a very complicated one, because hydrogen is interesting because everyone wants to have some green fuel to avoid the carbon in the fuel and so on. And everybody, I mean, you have some clients who come and say, okay, we want to fire 30%, 40% hydrogen, but nobody's thinking about the cost to produce the hydrogen. So we are in talks with several parties, but we are making tests with, let's say, low percentages, which are realistic for the process. But what you have to see when you produce the hydrogen, you're also producing oxygen. If you're not using it, what are you doing with the oxygen? And as I said, still the economic factor is a big factor. And I think as hydrogen it's not so easy to control because of the very fast reaction of the hydrogen. This is what we are testing at the moment. If it will be used, then it can be used, as you said, to enhance the existing flame at low percentages through the kiln. Otherwise, I don't think this is will be the future of the cement production.
Okay, very interesting. Well, it'd be good to hear how those tests go, but it's obviously an area of interest for the reasons you stated. Thank you very much for your presentation.
Thank you very much.
Pretty excellent. That's Reinhard from Unitherm Cemcon.